All right, if you're a developer, you know this feeling. It's like a classic tug of war, right? On one side, you've got this pull for raw, just blistering performance. But on the other, you've got developer productivity and, just making things easy to build. So where do modern Java frameworks even fit into all this? And is chasing that last request per second even worth it for most of us? Okay, let's get into it. So, believe it or not, this whole explainer got started from a really fascinating thread on Reddit. Some developer went and benchmarked a bunch of frameworks, not just Java, but stuff from the outside world too. And then this one comment from a user, Sheldor5, just it cuts right to the heart of the whole problem. They basically said, are we even comparing the right things? And that's the big question we're going to dig into.
Okay, so that leads us right into our first section. We're going to really unpack this whole performance debate and try to figure out what actually matters when you're building something for the real world.
So the person who kicked this all off, right? After running all these tests on Spring Boot, Vertex, even Rust, they threw this question out to the community. They were seeing these massive differences in just raw speed for simple stuff like a JSON round trip. And they just wanted to know, do these little isolated tests, these micro benchmarks, do they mean anything in the real world?
And wow, the community response was, well, it was loud and clear. This one quote here from user Googlin Noob just nails it. The consensus was, for most apps, the framework speed is a tiny, tiny piece of the puzzle. The real performance killers? We're talking slow database queries, clunky business logic, waiting on external APIs. The framework itself, it's almost never the bottleneck. So it all boils down to this classic trade-off, doesn't it? On one hand, you've got that raw speed you see in a benchmark, but on the other, you have the developer experience. I mean, how fast can your team actually build, test, and maintain the thing? And somebody else in the thread pointed out something huge. For most companies, developer time is the most expensive resource. So at the end of the day, productivity is what really moves the needle. Okay. Before we jump into the frameworks themselves, we've got to take a quick step back. It's super important to understand the modern Java tech that's making these high-performance conversations even possible. Seriously, the Java ecosystem has changed a lot. So what's so cool about this stuff is how it directly tackles the big headaches of modern cloud-native development. Let's start with GraalVM. This is a total game changer. It takes your Java code and compiles it down to a native executable, just like you'd get with Go or Rust. And the result? Your apps start up almost instantly and use way, way less memory. That's a huge win for things like serverless and containers. Then there's ahead-of-time compilation, or AOT. This is where the framework does all its thinking at build time, not when the app is starting up. It just slashes those boot times. And then, the big one, virtual threads. Okay, think of it like this. In the old days, one operating system thread handled one user request. That's it. With virtual threads, a single one of those real threads can juggle thousands of requests. It's like one postal worker handling thousands of letters at once instead of just one. You get this massive concurrency without all the messy, complicated async code. It's amazing. All right, so with all that technical horsepower under the hood, let's meet the main players on the field today. We're talking about the lightweight, high-performance frameworks that are pretty much dominating the Java microservices world. This table gives us a really nice lay of the land. First up, Spring Boot. I mean, it's the undisputed king of the hill, right? The de facto standard. It has a massive community and a library for literally everything. It's the safe, powerful choice for big enterprise apps. Then you've got the modern challengers like Quarkus. This thing was built from the ground up for the cloud. It uses stuff like GraalVM to give you super fast startups and a tiny memory footprint, perfect for serverless. Vertex, that's your master of high concurrency. It's non-blocking to its core. Think real-time data streaming, that's where it shines. And finally, Micronaut, which is all about pure efficiency by getting rid of reflection entirely. Okay, let's actually look at some code. So this is a super simple endpoint in Quarkus. See those annotations, @path and @get? Those are standard Jakarta EE. And this is exactly why Quarkus is so brilliant. It gives you all that modern cloud-native performance, but it lets you use the standards that millions of Java developers already know and love. It's the best of both worlds. Now let's switch gears and look at Vert.x. It's a totally different vibe. Here, you're extending what's called an abstract vertical, and you handle the request inside a Lambda. This style is way more explicit about its whole event-driven, async nature. It gives you this incredible fine-grained control, which is exactly what you want for those high-throughput data streams or real-time apps. And then we have Micronaut. Now, at first glance, this looks really familiar, right? At controller, at get, it feels a lot like Spring. But the real magic here is what's happening behind the scenes. Micronaut figures out all its dependencies and wiring at compile time. It completely avoids the performance hit of reflection at runtime. It's just all about being lean and efficient, right from the very start.
So we've seen the big players, right? They're all packed with features. But what if the best path to better performance and productivity isn't about adding more stuff, but about taking things away? This brings us to a challenger with a totally different way of thinking.
Let me introduce you to TinyStruct. Its whole philosophy can be summed up in 3 words: minimalism done right. The idea here isn't to give you a kitchen sink of features. Nope. It's about giving you the absolute essentials and then just getting out of your way so you can focus on what really matters, your actual application logic. So what does minimalist actually mean in practice? Well, for one, it's a zero overhead architecture. No reflection-based scanning, no confusing auto-wiring maze to get lost in. It also has this really cool unified design where a command line app and a web app are basically the same thing, built from the same code. And, of course, minimal configuration. The whole point is you spend less time fighting with the framework and more time writing the code that your business actually needs.
Okay, so that's the philosophy. But talk is cheap, right? What does this look like in the real world? Let's get away from the theory and look at some hard numbers and actual code to see how this translates to performance and simplicity.
So what kind of performance are we talking about here? Well, according to a benchmark on their GitHub page, we're looking at over 86,000 requests per second. Now look, we've already established that micro benchmarks aren't the whole story. We get that. But a number like this really shows you the kind of raw power and efficiency you can unlock when you just strip away all that extra overhead. And this is the code that gets you that performance. I mean, look how simple it is. You just extend a class, use an @action annotation for your root, and then you write your method. That's it. There's no complex setup, no wrestling with dependency injection. It's just a straight line from the incoming request to your business logic. This really highlights a whole different way of building things. A really cool feature is that there's no mandatory main method. You launch it straight from a command line tool. And this unified approach makes it perfect for things like script automation, data processing, maybe even AI tasks. Anywhere that having a command line interface is just as crucial as having a web API.
Okay, so we've seen the big, feature-packed enterprise giants, and we've seen the lean, mean, minimalist challenger. Which brings us right back to where we started. How in the world do you choose the right tool for your job?
And the answer, of course, is that there is no single best framework. It's all about context. But we can build a kind of mental guide. Look, if your number one priority is a huge ecosystem, easy hiring, and rock-solid stability for a giant enterprise app, then Spring Boot is your fortress. If you're building specifically for the cloud, serverless, containers, fast startups, then Quarkus and Micronaut were literally born for that world. If your whole business depends on handling a fire hose of real-time data, Vertex is your tool. But if the biggest problem you're fighting is complexity itself, and you want to let a small, smart team move at lightning speed, then the minimalist philosophy of something like TinyStruct starts to look really, really attractive.
And that leaves us with one last thing to think about. A final, important question. As you're planning your next project and looking at all these options, ask yourself this. What's the real bottleneck I'm trying to solve here? Is it the framework's raw requests per second? Or is it the complexity that my team and I will have to live with every single day for the life of this project? I think the answer to that question will tell you everything you need to know.